Good afternoon, students. So last class we discussed about the classification of distribution system. Under that one, depending up according to the type of connection, according to the number of wires, according to the construction, right? So distribution system may be classified into in different manners. So overhead, underground. So and also according to current, AC, DC, connection, radial, ring main, interconnected, wires, 3-phase, 3-wire, 3-phase, 4-wire, single phase, 2-wire, like that. So under that one, we discuss about the difference between the AC, DC, and also overhead and underground, and primary, secondary also. And also extra concept, that is design rating of the distribution system and design consideration of the distribution system. Proper voltage, power on availability, otherwise availability on power demand, and also next to reliability. That is the rating. And design means feeder, distributor, service. Now we go for the according to the connection. The distribution systems are classified as radial, ring main, interconnected. Now we can clearly explain the connection scheme of distribution system. So all distribution of electrical energy is operated with a constant voltage, approximately plus or minus 6, that is 214 volts to 240 volts, 244 volts. Why? Because plus or minus 6% of 230 volts is nothing but 14 volts. So 230 minus 14, 230 plus 14, that is 216, 244. That is a constant. In between these two, we can consider as a constant voltage. So depending upon the rating or voltage, constant voltage, the radial system, ring main system, and interconnect system. Generally, radial system, so we are utilizing mainly in rural areas, and these are operated with a separate feeders, so they don't combine to each other. Individual feeders operated their own individually. So that is nothing but suppose taking one distributor, that is will be ending at the end, far end, dead end, and that dead end connection does not connect to the another section. That is nothing but radial system. So it may be going. Every feeder is its own individual. So look at the figure. So this is the from figure 1, a single line diagram of radial system, right, for DC distribution system, where a feeder here this is the feeder OC is the feeder, supplies a distributor AB is the distributor at a point A. So feeder OC supplies a distributor at a point A, right? That is nothing but every feeder has its own. They don't combine this feeder. They don't combine this feeder. The individual OC, suppose it is a AB, AD, CD, DE, another name, whatever it may be. This is also another feeder. So this feeder, and this feeder does not combine together. They are operated individually. Coming to the second line diagram, it is also a single line diagram. It is for AC systems, not for DC systems. So this is figure 1 diagram is used for DC system, DC radial line, single line diagram. And the figure 2 is AC distribution system. So here, as usual, OC is the line and AB is the distributor. So feeder, there is no step down the voltage. Only in distributor only voltage will be stepped down from 11 kV to 230 volts or 400 volts. Why? Because so this transformer is nearer to our houses. So these are the our houses. Look at loads, different loads. Tappings are there. In feeder, there is no tappings. You cannot directly take in the consumers from the feeder. You can take in the supply from distributor only. Suppose, is there any problem occurred in the at any point of the line? Total system will be shut down. So total system will be shut down. Main advantage. What is the advantage of radial distribution system? Is nothing but it is a simple. Look at the picture. The simple one. So line. There is no combination of any two feeders. There is no any combination of two distributors also. So just individual. So that's why it is a simple, right? And as low initial cost. Initial cost is very low. So even though apart from these two advantages, some main disadvantage also there. So look at the figure. At the end of the distributor, suppose at point B, so many members are added in their own way. They don't ask the distribution company. Some of the members may theft also at that time. So at the load end, the load will be varies. So at the end of the distributor, so that is nothing but heavily loaded sometimes. So it may be heavy loaded. Whenever heavy loaded, load variations will be comes. So last class we discussed proper voltage. We have to provide proper voltage. Why we have provide proper voltage? So to consume electrical power. So many consumers may consume the electrical power, because that's why we have to attract the people. Even though load changes means voltage must be changed. So due to that voltage variations, so faults will be up and down voltages, low voltage, high voltage will be appearing. So where low voltage, what will happen? High voltage, what will happen? Last class we discussed, right? So here at the end of in radial feeder, advantage is nothing but simple and low initial cost. Disadvantage at the far end, otherwise at the load end, the distributor may be heavily loaded, right? Second one is consumers may depend on the single distributor, right? So any consumer, so look at the one, right? Consumer are depend on a single feeder and single distributor, right? So that is nothing but there is suppose power will be shut down, the consumer does not depending upon another feeder. So whenever again power will be given by the distribution company, up to that time the consumers may wait. That is the big problem. So consumers does not depending on the remaining feeders. They will depending only single feeder. So what will happen? Any fault on the feeder or distributor cut off the supply to the consumers who are on the side of fault away. సో ఎవరైతే ఆ ఫీడర్లో సప్లై తీసుకున్నారో ఏదైనా ఫాల్ట్ వచ్చి షట్ డౌన్ అయితే కంప్లీట్గా అప్పుడు దాకా వెయిట్ చేయాల్సింది. మళ్ళీ ఫాల్ట్ రిపేర్ చేసేంత, ఫాల్ట్ని ఐసోలేట్ చేసేంత. నెక్స్ట్, ది కన్జ్యూమర్స్ అట్ ద డిస్టెంట్ ఎండ్ of the distributor would be subjected to serious voltage fluctuations and the load on the distributor changes. So this is also first problem. So voltage fluctuations are occur because of load variation. Why load variation? So heavily loaded. So that is the first disadvantage. Third means because of heavy loaded, voltage variation occurred. Because of voltage variations, voltage fluctuations will be occurred on the distributor. So that's why these are the main disadvantages. Heavily loaded at the end of the distributor, heavily loaded. The consumers may depend on single feeder, single distributor. Voltage fluctuations. So that's why. So this may, because of these disadvantages, radial system may utilize only urban systems till now, sorry, rural areas till now. So after maybe it may be replaced with ring main or interconnect system, maybe 10 or 20 years. After 10 to 20 years, total India may be converted to radial to ring main or maybe interconnected. So that is the radial system. Radial system is simply, it is not a reliable one compared to ring main. Why? Because supply, once supply shut down, total supply will be shut down. If any fault occurred in the feeder, total supply will be shut down. So that is the main problem of our radial system. There is no continuity of power supply. Right? Now go for the ring main system. So in this system, so the loop circuit are starts from the one substation or bus bars. It makes a loop through the area to be served and returned to the substation. That is nothing but to maintain a loop. Suppose the feeder will be started at the substation and it will be traveling so many distance, and again will comes and it will be end of that feeder is starting point. That means it provides a loop. So that makes, is there any problem occurred in the at one stage? There is no problem for another consumers. Only that consumer only may face the problems. So look at the figure. So this is the ring main system. Substation starts from like this and it will going here one distributor, coming here one distributor here, and it will be ending at the S only. Suppose the fault may occur in between L and M. There is no complete shutdown. Whereas in radial system, any fault occurred at any stage of feeder, total supply may be shut down, right? But this is not like that. Suppose fault occurred in between L point and M point. So the power will be, generally it is a radial system, total M distributor may shut down. But now, so there is no power failure for M distributor also, because so the power will be going S, R, Q, P, O, N, M like this. After isolating the fault in between L and M, again we have to provide the regular power. So this is the distance. Suppose fault will occur, this is the distance. That means there is no cutting off supply. There is no it will provide the continuity of power supply mainly. So whenever it will provide the continuity of supply, automatically reliable system more. So more reliable than radial system. Why? Because we are providing the continuity of supply, and economical also. So economical. Why? Because don't repair again and again. So right, next, it is more flexible than radial system. Right, flexible means at one substation we are providing so many consumers, but radial system single feeder. For that feeder rating, according to that feeder rating, consumers may given to the supply. So whereas in ring main system, so many feeders will be there. So Q feeder, O feeder, M feeder, right? So like that, it is more economical, and all loads are equally loaded, not heavily. Far end load is heavily loaded, and near the substation low loaded not. Whereas in radial system, far most of the distributor may be heavily loaded. So, but coming to the ring main system, all the ends, suppose M at the end of the M distributor, end of the O distributor, end of the Q distributor, all are equally loaded. There is no voltage there is no voltage variations, right? All are equally loaded is nothing but voltage fluctuations are less. And also fault in any section can be isolated without it discharging the faulty section. సో ఫాల్ట్ ఏర్పడిన దగ్గర మనం డిశ్చార్జ్ చేయకుండా వేరే పాత్ ద్వారా వాళ్ళకి సప్లై ఇచ్చేసి ముందర ఫాల్టీ సెక్షన్ని మనం ఐసోలేట్ చేస్తాం. ఆఫ్టర్ ఐసోలేటింగ్ ద ఫాల్టీ సెక్షన్ వీ హ్యావ్ టు ప్రొవైడింగ్ ది రెగ్యులర్ పాత్ ఓన్లీ సప్లై in a regular path. So because of the disadvantages, far-end distributor heavily loaded, voltage fluctuations are more, right? So radial systems are used for short distance only, that's why rural areas. Whereas coming to the ring main system, so many advantages is there, that's why it is used for long distance and bulk load applications. Even though it will having some disadvantages, so fault current is more in this system. Suppose fault is occurred, that fault current may be high. So fault current high means auxiliary equipments may burn. So next, it requires high degree of protection to ensure the continuity of supply. Why? Because magnitude of fault current is more means, so to protect that all equipments, so from that fault current we may provide highly secured, highly protection for each and every equipment. Why? Because to provide a continuity and reliable power supply to the consumers. So these two are the disadvantages of ring main system. And interconnect system is not in syllabus, that's why I am not putting in the slides. Now go for the so till now we discuss about the classification, design and rating, differences and connection scheme, right? So up to this syllabus maybe we have to expect only half question, that may be design and rating of, that is the important. Sometimes they ask in difference, sometimes they ask in classification also, but most of the time only the asking question is, so design distribution system and explain rating of the distribution system, that is proper voltage, availability of power on demand, reliability, feeder, distributor, service, right? So next, so this is the radial type primary feeder, not a radial distributor. So last we discuss about the radial distribution system. Before 10 minutes we discuss about the radial distribution system, ring main distribution system. So it is not a radial distribution system, it is a radial type primary feeder. Feeder, types of feeders. So generally feeder is there, distributor is there. So now feeder, what are the different types? So most important question, most of the time they are asking, explain the radial type primary feeder or sectionalized primary feeder or express feeder, like that they are asking. Just small diagram and 2 or 3 lines enough. So very important. Generally the feeders may be utilized to transfer the constant voltage to the distributor end. That's why it is the simplest and lowest cost. Whenever you have to provide the constant voltage, that means there is no problem. That's why simplest and lowest. Why simplest is nothing but single path, there is no tappings. Simple and lowest cost, and therefore the most connected from the primary feeder is the radial type primary feeder. So before 10 minutes, what are the advantages of radial distribution system? Simple and economical, low initial cost. So because of simple and economical, low initial cost, so most common type of primary feeder is radial type primary feeder, right? The main primary feeder branches into various laterals, which in turn separates into several all the distribution transformers. Look at the picture. The main primary feeder, this is the distribution substation, and this is the feeder, main primary feeder, this is the main primary feeder. Up to this one to starting point to ending point is the main primary feeder. Now these are the branches. Branches is nothing but laterals. Laterals. So this is the main primary feeder, and this is the lateral feeder. This is also lateral feeder, and again the lateral feeder also again classified into sublaterals. Sublateral. This is the main complete main primary feeder, and these are the laterals and these are the sublaterals. So all are depending upon the main primary feeder only. So in general, the main primary feeder and sub feeders are three-phase, three-wire or four-wire systems. So main primary feeder or sub feeders may be a three-phase three-wire or three-phase four-wire circuit, and the laterals are three-phase or single-phase. So sublaterals are maximum single-phase, or it may be sometimes three-phase also. So the current in magnitude is the greatest in the circuit conductors that leave the substation. The current magnitude continuously flows through towards the end of the feeder as laterals and sublaterals are tapped off the feeder. Usually the current lessens. The size of the feeder conductors is also reduced. However, the permissible voltage regulation and restrict any feeder size. So always the current may flowing from the up to downwards and laterals and sublateral also. So and size of the feeder is also reduced. So however, the permissible voltage regulation and restrict any feeder size. To maintain the voltage fluctuations plus or minus 6%. That's why you have to resize the feeder also. The reduction, how can you reduce the feeder size means with the help of thermal capability. Thermal capability means mechanical strength. Mechanical strength. So current carrying, or it may be current carrying capacity of the feeder. Why? Because feeder is designed based on current carrying capacity right now. So that's why. So suppose is there any voltage fluctuations occurred in the feeder, we may resize the feeder. It may be laterals or sublaterals. That may depending upon the thermal capability. Thermal capability in the sense, so current carrying capacity of a feeder, right? Figure easily write down simple feeder. So ఇక్కడ 3A ఉండాలి, ఇక్కడ 4 ఉండాలి, అవి మీకు ఎవరేం అడగదు. మెయిన్ ఫీడర్ డ్రా చేసుకొని సో లైట్ మీరు ఎన్ని గీసుకుని మంచిది, కాకపోతే క్లియర్గా ఎక్స్ప్లెయిన్ చేస్తే సార్. Now the reliability of service of continuity of the radial primary feeder is very low, right? So as you discussed in the radial distribution system, there is no continuity of power supply, right? That's why reliability is low, continuity of power supply is also low. Why? What is the reason? A fault occurred at any location on the radial primary feeder may cause power shutdown or power outage for every consumer for that particular feeder. Whenever the fault may isolated, then only again the power will be provided to the consumers. So now this disadvantage, continuity of power supply, reliability will be less for radial type primary feeder, right? So to improve that reliability of supply, to improve that continuity of power supply, we may small change for this radial system. This is the radial system, and we have to improve that some of the betterment. Then we may reduce that two disadvantages, right? So for that one, go for the sectionalized radial type primary feeder with the tie and sectionalized switches. Tie and sectionalized switches, right? So so this is the tie and tie switch normally open, tie switch normally open, right? Whenever fault will be occurred, so this is the main primary feeder, this is the main primary feeder, and these are the laterals like this, laterals. So these are the breakers, sectionalized switch. These two are the sectionalized switch. These are the tie switches. Tie means normal switches. This is the sectionalized switch. So now suppose fault may occurred at any, suppose fault may occurred in the down section, fault may occurred in the down section means, so we may shut down the, we may close the tie switch. Normally open, whenever fault occurs it may be closed. That may help the so sectionalized switch. Sectionalized switch also closed, and the power will be going to the through the sectionalized switch, and the fault is after faulty section will be isolated, and again so we have to open the tie switches, and sectionalized switch also open. So this is the radial type primary feeder with the tie and sectionalized switches. So it is not exact economical, it was so many switches are used, that's why cost wise it is more, but we have to provide continuity of power supply, or we may provide more reliability compared to radial primary feeder, but cost wise is more, that's why we go for another one. So that is radial type primary feeder with express feeder and back feeder, express feeder and back feeder. So the dots, all the dots are distribution transformers, right? So this is the another type of radial type primary feeder with the express feeder and back feeder. The section of the feeder between the substation, low voltage bus and the load center of the service area is called express feeder. So this from this point to this point is called express feeder. So I think on examination, define express feeder, they are asking 2 marks. The feeder is located in between substation, low voltage to load center of the consumer or of the service area is called express feeder. So from the express feeder there is no tappings, there is no extra feeder, only single feeder is there, right? However, sub feeder is allowed to provide back feed towards the substation from the load center. That means sometimes they may given some back feed to the substation. So there is no tappings from the express feeder, but sometimes so they may provide back feed to the substation like this, like this. So how can you provide a continuity of power supply means, if the fault is occurred at any line, we may provide power supply through the express feeder, that is the main, and may provide for this section it may provide back feed, that's why it is more reliable, right? So another one is also there, that is the radial type phase area feeder, phase area feeder. That means this is also same as radial type primary feeder, but we have to distribute every area, phase A area, phase B area, phase C area. For that phases we have to provide the supply. Is there any fault occurred from the phase A, fault occurred from phase B to, you have to provide the phase A, and phase C also like that, we provide the faulty sections. Right, every dot 3-phase load, 3-phase load, every dot 3-phase load lumped at the their own location. So this is the 3-phase main, and these are the laterals, and these are the single phase main. So like that, total complete main feeder is 3-phase. So laterals are single phase, phase A single, phase B single, phase C single, like that. They may provide their own phase only. So supply may provide, their phase B may provide phase B load area only, phase A provide phase A load area only, phase C provide phase C load area only, right? And this is not in syllabus. Suppose they asking question, very important. Explain the radial type primary feeder, means you have to write all the things. So radial type primary feeder and sectionalized switch, express feeder, area feeder. Suppose for 10 marks they asking like that. Suppose 5 marks they asking this one mainly. First one and third one. Radial type primary feeder and express feeder they asking. Just diagram 5 marks. There is no matter. Just diagram 5 marks only. So you have to practice simple way. Very important question. And all the radial systems may suffer some continuity of power supply, but compared to all the radial type primary feeders, loop type primary feeder is the best one. That means suppose look at the figure here. From the distribution substation the feeder way started like this, and it will be come back to the same. That may provide loop. Suppose we may provide some tie switches also like this to disconnect the faulty section, right? We have to provide tie switches like this. So that means we have to isolate the faulty section, right? So tie switches are there. Suppose fault may occur in this section. By using this tie section, so may disconnect the supply and may isolate the fault here, right? Usually the size of the feeder conductor is kept same throughout the loop, right? So in radial feeder size may reduced from the starting to ending, right? From the starting size may more and the ending size may reduced, right? But coming to the loop, so size may same throughout the loop. It is selected to carry its normal rating. This arrangement may provide two parallel paths from the substation to the load. When the loop is operated with normally open tie breakers, or it may be, you can call it as a disconnected switches. Suppose a fault occurred on the feeder, the tie breaker may open and breaker will remain open until the fault is isolated from both directions. So in this section, fault occurred means this tie breaker and this tie breaker both are open. After isolate the fault, you can provide the supply. The loop type primary feeder arrangement may provides the high reliability, high security of service. That is the most important one. Generally, for every section extra feeders also there, separate feeders also there. So even though we have to provide extra tie breaker for separate feeders like this. In addition to the main feeder loops, normally open laterals are also used. This is the loop type primary feeder, but they don't ask any time. They asking only explain the radial type primary feeder or sectionalized switch, tie and sectionalized switch radial type primary feeder, or express feeder or back feeder, otherwise area feeder. Most of asking 10 marks question. Suppose they asking 10 marks question, you can write all things. So 5. So you can write loop also. So 10 out of 10. Why? Because 5 diagrams are there. 5 to 10. So that is the most important question, right? and I am not putting the difference between radial primary feeder and loop type primary feeder. Loop type primary feeder, because sometimes they ask me 2 marks. Radial distribution, ring main distribution, similar to the radial type primary feeder, loop type primary feeder. Both are different, right? So you can call it in different manner, but methodology is same. Reliability is more, reliability is less, quantity of power supply is more, quantity of power supply is less, like that. So radial is means most simple and economical, right? And loop type is a bit complex compared to radial type. What about reliability? Reliability in radial type is less, whereas loop type is very high. Cost, radial type is low, loop type is high. Size of the conductor is very less, but size of the conductor is high in loop type, right? Switching equipment requirement is less for radial type. Why? Because there is no most equipments used in the radial type, but switching equipment requirement is very high. Why? Because on the loop is there, and every loop having every section having their own sub feeders also there. That's why we have to provide equipments, switching equipment. I mean protection devices. Operation, easy to operate radial system, so difficult to operate loop type primary feeder. Losses very high in radial type primary feeder. Losses are very low in loop type primary feeder. Radial type primary feeder may provide low voltage profile, but this is not provide a low voltage profile. It will provide a good voltage profile. Loop type primary feeder may provide a good voltage profile, right? This is about connection scheme of a distribution system and radial type primary feeder. Next one problematic, and but this derivation also very important. Methods of solving AC distribution problems. Power factor referred to receiving in voltage, power factor referred to respect to load voltages. Same topic may again appear in 4th unit. Manual calculation of distribution system. In 4th unit, the topic name is manual calculation of AC distribution system. Here, methods of solving AC distribution system or AC distribution problems. Both are same, ditto. We have to learn this topic in this unit, so that may be utilized in 4th unit also. Sometimes in 2nd unit they are asking problem, sometimes in 4th unit they are asking this theory, derive the manual methods of AC distribution system. At that time, so these two, power factor referred to receiving in voltage, power factor referred to respect to voltage, you have to write down. Generally this is a problematic, so I can explain next class, right? So till now in 2nd unit we cover the classification, differences, design and rating of the distribution system, connection scheme of distribution system, radial type primary feeder with the tie and sectionalized, with express feeder and back feeder, and aerial feeder, and also loop feeder, right? So next topics are this one, methods of solving AC distribution system, and also voltage level and design of secondary distribution system, right?